Let's take a quick look at a problem from the chapter 2.3 homework. That was where we were learning basic polynomial kind of rules. Question B gave us a piecewise polynomial that looked like this. And question C gave us a cubic that looked like this. We'll say piecewise, this was a piecewise quadratic. And this was just a plain cubic. And by eye, they look pretty similar. Like maybe the heights are a little different. But the question is, can we really tell the difference between them in their behavior? If you take the derivative of the cubic, you get a parabola, and it looks like this. If you take the derivative of the piecewise quadratic, well, the piecewise of a quadratic, the derivative of a quadratic is a line, and you get a different lines for the different halves. So you get something like this, and then like that. So can we tell the difference between these two curves by eye? The original curves, no. The derivatives, on the one hand, look very different. This one has a sharp corner. This one is nice and smooth. On the other hand, they're both kind of upside down shapes, and they both don't peak right at the origin. They peak a little above the origin. So there's some similarities and some differences. And then if you look at f double prime, the derivative of this one, derivative of a straight line is a flat line, and it has a positive slope, so it's coming over like that. Derivative of this flat line, of this slanted line with a negative slope, is a negative flat line, and the derivative right at the right at that peak does not exist because it doesn't agree from both sides. So we'll draw a kind of a hole in the graph. And what is the second derivative of this, or the first derivative of that? Well, it's a parabola, so the derivative of a parabola is a straight line. This is a downward facing parabola, so it's going to be a negatively sloped line. So we get that. So how are these second derivatives the same or different? Well, this one obviously has a sharp jump, and this one is a nice and smooth plain line. But they are kind of similar. Like this one is in the third quadrant, the second quadrant, and the fourth quadrant, and so is this one. So you could say this one is kind of a smooth version of that, maybe. So it's interesting to think if this was like a piece of railroad track or a roller coaster track, they both look smooth, and this one is actually smooth as you go around the bends here. But here you'd be kind of thrown to one side, like pushed to one side of the car as you're doing this curve, and then pushed to the other side. But it would be a sharp transition from one to the other. You would like get slammed against the other side, whereas this one you would gradually ease off on getting pushed to one side, be in the center, and then you'd kind of gradually ease into getting pushed to the other side. So when they design train tracks and roads and roller coasters, they really have to think about this kind of thing. They can't just piece together polynomials willy-nilly because they'll end up throwing their riders around. So interesting engineering stuff, huh?